Welcome to Brain Vision.
In this problem, two rods are kept perpendicular to each other and each has length 1.2 meter. Now, both are equally charged in magnitude but they have opposite signs. First rod has positive charge while the second rod has negative charge. Now, in first part, we have to find net electric field at point P, which is at 0.6 meter, that is 60 centimeter away from both the rods. All right. So to find the electric field at point P, first of all, let us look at the directions in which direction they will be directed. So because of this positive charge, if we talk about this horizontal rod, then because of these charges, positive charges, electric field will be directed away from the rod. So it will be in the perpendicular direction. So electric field due to this positive rod will be in the downward direction, and let us say this electric field is E1. All right. Now because of this negative rod, the electric field will be directed towards the rod. So it will attract the electric field, or the electric field will be directed towards the rod, and let us say that this electric field is E2. Now we can observe here that both the rods have same magnitude of charge, that is 2.5 microcoulomb, and both the rods are at equal distance from the point P. Therefore, magnitude of E1 and E2 will be equal. So what we can say, E1 will be equals to E2 because of the symmetry. This modulus sign indicates that their magnitude will be actually equal. Now, question is how to find these magnitudes. So for that, we will recall a formula that is used to calculate electric field for a uniformly distributed rod. So let us say this is the rod on which Q charge is uniformly distributed over its entire length L. Alright, and we have to find electric field at point P, which is at a distance r from the rod. So if we join the end of these rods, then let us say it is going to make an angle of theta 1 and theta 2 with the rods. Okay, now how to find electric field at point P? So electric field at point P is given by the formula KQ divided by LR into sine theta 1 plus sine theta 2. Okay, so what is here? K is representing, K is Coulomb's constant, Q is the charge which is distributed over its length, L is the length of the rod. Okay, small r is the perpendicular distance of the point from the rod. Theta 1 and theta 2 are the angles made by the end point of the rod with the perpendicular to the rod from the point P. Okay, so by putting these constants, we can get the value of electric field at the point P. So we will use this relation to calculate either of E1 or E2 because their magnitudes is going to be same. So what will be the value of E1? So if we go to calculate E1, first what is the value of K? K is Coulomb's constant and its value is 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Okay, so this is Coulomb's constant K. The second thing is Q, that is charge, and charge is 2.5 microcoulomb. So micro, to convert micro into coulomb, we have to multiply it by 10 raised to the power minus 6. So it will be in coulombs unit. Now this is KQ divided by L. What is the length of the rod? It is 1.2 meter. Okay, and the third thing is small r. So what is the small r? Small r was the perpendicular distance, and perpendicular distance in both the cases 0.6 meter, that is 60 centimeter. So we will put its value in SI unit, so it will be 0.6 meter. Okay, now we have to put the value of sine theta 1 and sine theta 2. How to get these values? So for that, we will join the end points of the rod with the point P. Okay, now this will be theta 1 and this will be theta 2. Now if we have drawn a perpendicular, So it will divide these rods in two equal halves. So it will be 0.6 meter, and the second half again will be of 0.6 meter. So it is also 0.6 meter. Now if we talk about the first triangle here, this right angle triangle, so in this right angle triangle, base is 0.6 meter and hypotenuse is 0.6 meter. It means that it is an isosceles right angle triangle. And what is the property of an isosceles right angle triangle? That its base angles are equal, and that is 45 degree. So both of these angles are 45 degree. it mean it means that this angle is 45 degree. Now again the same thing will happen with the second right angle triangle. So again this angle is going to be 45 degree. So it means that in this case theta 1 and theta 2 are 45 degree. So this is theta 2, let us say, and this is theta 1. So we have to multiply this factor here. We need few more space. So okay, so we have to multiply with sine theta 1, that is sine 45 degree, plus again sine 45 degree. Okay, so we can solve this value. So E1 comes out to be 4.42 into 10 raised to the power 4 Newton per coulomb. So this is the value of E1. So the same value will be for E2. Now the question is how to find net electric field. So we can see here that these two electric fields are perpendicular to each other because these two rods were perpendicular to each other. Therefore, their resultant field will lie in between them. So let me draw these two fields again. This was E2 and this one was E1, and both were of equal magnitude. So it means that they were at perpendicular to each other. So if they are perpendicular to each other, then their resultant electric field will be at an angle of 45 degree because of the symmetry. So this will be the net electric field. Now how to calculate the value of net electric field for two perpendicular fields? So net electric field magnitude will be equals to square root over magnitude of first electric field, that is E1 square, plus magnitude of the second electric field, that is E2 square. Now both of these are equal, so we can write it as 2 times E square. Now what is E? E is the magnitude of the any of the electric field that we have just calculated. So it will be equals to square root of 2 multiplied by E, that is E1. So it will be 4.42 into 10 raised to the power 4 Newton per coulomb. Okay, so this comes out to be 6.25 into 10 raised to the power 4 Newton per coulomb. So it is the value of or the magnitude of the net electric field. Now what will be the direction? So clearly we have just observed here that the net electric field will be directed in the downward direction at an angle of 45 degree with the horizontal. So what we can write here is that net electric field will be 6.25 into 10 raised to the power 4 Newton per coulomb. And how to write its direction? So its direction will be in the downward direction at an angle of 45 degree. So this is the answer for first part of the problem. Now moving to the second part. In second part, it is saying that an electron is kept at the point P. Okay, so at point P, what will be the net force acting on the electron and in which direction it will be acting? So we know that force or electric force is given by the relation charge of the charged particle into uh, into net electric field at that point. So first we will calculate magnitude. So magnitude of the force will be equals to magnitude of Q into magnitude of E. What is the magnitude of charge on one electron? It is 1.6 into 10 raised to the power minus 19 coulomb. And what is the net electric field? So as we have just calculated, net electric field is 6.25 into 10 raised to the power 4 Newton per coulomb. So it comes out to be uh, 1.6 into 6.25 is 10, and 10 raised to the power minus 19 into 10 raised to the power 4, it will be 10 raised to the power minus. So and coulombs get cancelled, so the remaining term will be Newton. So it is equals to 10 raised to the power minus 14 Newton. So it is the magnitude of force, but the question is in which direction this force will be directed. So as we know that this electric field is directed at an angle of 45 degree in the downward direction. Therefore, and this charge, that the charged particle that is kept at point P is a negative particle. So on negative particle, so this negative will be multiplied with this electric field vector. So direction will be opposite. So if electric field was in downward direction, so force will be in the upward direction. Now, as if we draw this angle, so this, if this angle is 45 degrees, so this angle will also be 45 degree. Therefore, what we can write about force? So force on electron will be 10 raised to the power minus 14 Newton. And in which direction? So its direction will be making an angle of 45 degree with the horizontal, and in this direction the net force will be acting. Okay, so this is going to be our direction, that is opposite to the electric field. So this is the answer for part B of the problem.